our presentation is how a commercially off-the-shelf deployable structure approach could make advanced nano and picosat missions possible, because that is something that we thought for a while now, is really how the space industry needs to be changed to make launching spacecraft and to really building these spacecrafts be much more affordable than what has been happening with bigger spacecrafts. There's the whole idea in our company, DCUBED, Deployable. So I'm Thomas Sinn, I'm the founder of DCUBED, and I'm here with my colleagues working in the background. Alex, Thomas is walking through the picture now, and Joram. Yes. So yeah, you also see it back with our logo. So quick thing about us, we started this adventure with our own company last year. At the PocketCube workshop last year in October, it was one of our first real outing scenarios. Very nice to get to talk to all of you. And there has been also some great developments that came out of this PocketCube workshop. So we are DCUBED. We are located in Gilching. That is where we are registered, because we are still incorporated or accelerated by the Business Incubation Center of the European Space Agency, still till next year in April. But since beginning of September, we have our own office here in Germering. We have in the basement a nice workshop, tool shop, and some 3D printing areas, while up here we have the office, our meeting room, the launch pad. So it's a quite nice upgrade. Because for that, due to Corona, we had to move out of our old offices in the Hochschule and move into a basement where we have been working for the summer. But there's a couple startups that also started in a garage or basement, and they made it big. So we hope this is also our direction. A quick thing that we also supported by various European organizations like Space Hub Astropreneurs, really trying to help small companies, especially thrive in new space applications. And we are very happy to be accepted in the German accelerator, where we're also trying to establish a strong market presence in the United States. Because unfortunately for European standards, the US is still the biggest market for new space. And that's where also most of our customer and project partners come from, because here in Europe or in Germany, it's still quite slow. But for that, companies like are really pushing the boundaries here. On the right, you see some pictures of us renovating our new office. It's really a nice team. So that's just a quick overview about who we are in Deployable Cubed. The reason why we do what we do is because when you look at a launch, it did not change much from the early days of Apollo now to Falcon and so on, that you still need a lot of energy, like 95%, to bring the other 5% of the paying satellite up into space. And also you're very constrained in the volume that is available in this rocket. So one of the things is to make everything as small as possible. So we can, with commercially off-the-shelf electronics, like most of you are using in your PocketCube CubeSats and SmallSats, you can bring the satellite to really small form factor, and then you can store a lot of satellites in the rocket fairing. But many applications need bigger structures than in space. That'd be you need more power, you need a solar array, you need more data down with, you need a deployable antenna, and these are just a few examples. So one of the solutions around it is to go with deployable structures. So structures that are small on the ground and big in space. For example, here you see the sun shield of the James Webb Telescope that are now being readied for launch. And if you see the sheer size of it, you will never fit it in any kind of rocket. And so that's why you need to make it foldable and start small for launch. The other big advantage is of deployables that you don't need to make them so stiff, because a killer for spacecraft structures is normally the launch. So when you have big structures like big rigid antennas, they vibrate, and you need to make them very stiff that they survive the launch. But in space, you actually don't need stiffness. And here you see it, it's really thin structure, it's really thin foil, just like 12 micron thick, these 5 layers. And that's something that you can do with deployables. So deployable structures could be deployable habitats, like space station, like what Guido was doing before he went bankrupt. But there's also a lot of other ideas from SpaceX, and also NASA just released a new nice video of how they want to colonize the moon and have deployable habitats on the moon and landing pads for their 3 missions. Other applications are spaceport power satellites, where you really have big structures in space. They collect energy and then beam it down via microwaves or lasers. Other applications are solar cells, where you need a big area so that you can ride the solar wind, but you can also do it as a drag sail. You deploy it, and then you increase the area of the satellite and the orbit itself, therefore reducing space debris. And then one of the most interesting business standpoint are antennas and reflectors, because you need either a lot of power or a big reflector to bring a lot of data down, or to really have a quite detailed strip on the ground where you can measure data. The question is, how can this be used in a pocket cube, in a small, or in a CubeSat? Because these satellites are normally very standardized, and you're all working very hard to get all of the things that you need to have in this satellite inside the satellite, because deployables has always a big risk to it, because you don't know if they will work in space or not. That is actually something that we want to work at, is really how to get these deployables reliable enough, but not too expensive, so it also makes sense to use them at CubeSats and pocket cubes. So some of the examples where there's already used is like antennas, like the tape spring that you see here, or deployable solar arrays. So the challenge that we set ourselves is, it's very affordable to launch these hundreds and thousands of satellites. They're all in a box shape or cubes shaped, but you need these high performance mission when you're in space. And most of the products that are available right now on the market are either home built and with a very high risk of failure, or they are export regulated because they come out of countries that have export limitations. So that's why we set ourselves, we really want to either go to shop or go to stop to provide these new deployable structures for the whole new space pocket CubeSat community to an affordable price, and really work with the customer to figure out what we can help them with to utilize the space mission better. Our idea is to do it completely commercially off the shelf. That results in very economic price, fast delivery times. But we also have the potential to do customized approaches or customized designs, because our core technology will always stay the same, but we can modify the interfaces. They don't need to be re-qualified, because they are not in the load path and they are just 3D printed by us. And we make it all in Europe, so that leads to no export limitations. And from the technology where we are standing right now is first, we do an actuator, which is like the trigger of an umbrella. So for an umbrella, you trigger first the switch and then the umbrella folds. So the switch is practically our release mechanism. And then you have the umbrella, which is our deployable that we are developing. And this is completely passive deployed, so no motors or anything in it. So as soon as the trigger is triggered, it is deploying itself. And looking at the different applications we have. So right now we are working on a tiny pin puller and release nut. One of my colleagues, he also brought me the example, so you see how tiny it is. Where's the camera? Yeah, so it's really tiny. Right now it's with 3 interface legs, but we're also having without the legs, we're having it in different sizes. And the nice thing is with the reset, you just have a tool, a very simple tool that you put in the back to easily reset it, and the pin is out there again. So the 2 parts that we have is a pin puller. So it retracts the pin, and the other one is a release nut to screw in a bolt. And when it's triggered, the bolt with the nut where it's screwed in is released. And the applications we have is for triggering deployment of deployable structures. So they are hold down with a spring, and then this actuator triggers the release, and it deploys the deployable. Then it's a release for CubeSat deployers, which just open the door. And then we also have some applications for hold down release mechanism for rockets, so stage separation, releasing the satellite from the last stage. But also we have some more exotic applications, for example, lunar lander, where we release a rover then on the surface of the moon. Looking at the deployables, which I think is also quite interesting, there's different applications. So deployable antennas, reflectors. Here it's really for looking at what kind of frequency you want to transmit it. Because if you're going under 1 gigahertz, then you need to go bigger than the CubeSat standard. Also, if you want to go to higher frequencies, they're going to Ka band, you need bigger structures to get the bandwidth down that you want. Then other applications, solar arrays. Right now you have these solar arrays that are just coming out of the sides of the satellite, or you have solar panels that are directly all mounted. But we are looking into actually going much bigger, so going more towards 100 watt and more, just coming out of a 1U cube, because that could enable really high power communication missions and also electric propulsion missions, which is right now a lot of push in the industry. And of course, radiators is an important point, because when you have so much power, you need to get rid of the heat, and it can be only done with deployable radiators, because where should the heat go when you're in space? And another application is, of course, these sails, when you make it bigger, the drag sail area, and you deorbit quickly. But the question is just here where you will fly your satellites. So if it's below 500 kilograms, 500 kilometers, space debris is not a huge issue because the satellites will come down by themselves. If you're going over 750 kilometers, then drag sails don't make much sense because the solar pressure is higher than the drag. So it really doesn't make sense in a range from 450 to 750 kilometers for these satellites. So with that, I want to conclude and want to say that we would love to talk to all of you in the community to see how we can help you with making more of your mission. Because at the end, we are developing these components and subsystems, but we really need to have a better understanding what missions you want to fly, because it's a little bit of a chicken and egg problem. So we have the technology that enables new missions, but we need to know what kind of missions it should enable, that we can understand how we can adapt the design. So our approach is we start with one design, we'll publish it, and then we'll see what comes back, and then we modify it until we really get this nice bridge between amazing advanced mission and good product that it can enable. Because right now it's a new space gold rush, and we are the ones building the shuttles to it, so let us help you to find the gold. With that, I thank you very much, and I'm happy to receive any questions, but feel also free to check out our webpage or contact me via email. I'm trying to give you feedback very quickly.